Hello, everyone. In this video, we are going to conduct statistical analysis. Since I already learned the basics of R. So in R, we're doing the descriptive, inferential, and regression model. So how we started? Let's open the file statistical analysis.R. Okay, let's just run code line by line. So first we clear the memory, then we load the package data.table, then we load our data into our variable KCMO 2017. So for descriptive statistics, remember in SPSS, you click that analyze and give you descriptive statistics. You can show everything, right? In R, just use a function. Those are all system build function. Mean, okay? Mean of this quality service is 3.8. Okay, that's the Likert scale 1 through 5. Okay, mean of timeliness is 3.7, 3.87. Okay, 3.84, 3.87. And the customer service score is 4.25. Okay, median is just a function median. Okay, so we can run median for all the three. By the way, we have to click the see. Okay, so this is a customer survey data. Okay, we have 3 customer surveys: the quality of this service, the timeliness of this service, and the customer service, which means the representative you are talking to, whether they're friendly to you or not, right? You have different kinds of survey thoughts. You may give them a call to it's a call request to send your request, or whether this your request is resolved or not, and whether this request coming from which district does the request coming from. There are 5 districts here. Okay, how many days does it take to solve this request, and the type of the request, whether it's a vehicle parking problem, it is a mowing problem, pet problem, or capital problem, something else, right? Let's go again to see what else. Whether it's a public safety problem, something like that. Okay. Then we try to calculate the mean, the median, and mode of the 3 satisfaction score. In R, there's a function, system build function called mode. But this mode function is totally different from the statistical meaning of mode. So in statistics, as you learned previously, it's the most frequently occurred number, right? If number 5 occurs 3 times, and all other numbers occur 2 times, then number 5 is most frequently occurred number, right? That's mode. But mode in R is not that, does not mean that mode in R we can see here. It's a storage mode of an object. It's something fancy related to computer science, about computers. So it's not the statistical mode. So in order to get that, I built a self-defined function, get mode, right? Remember, we use a keyword function to define a function by user. So I define a function called get mode, and this is a syntax to calculate the mode, okay? And after I define this function, we just use it on those data, and we have the mode. Okay, let's get mode 555, which means 5 are the most frequently occurred value in those satisfaction score, which means many responded just sign 5. Okay, satisfied, yeah, 5, yeah, like something like that. Many of them, only a few of them come from very bad experience, problem not solved, so they will find even 1 star. You can see it on Google's review, right? But Google review is a different thing, because many people only feel unfairly treated. They just put it online on the Google review, say, oh, I was fairly treated. So that's kind of a bias. But for a random survey, it's more representative. Most people, when you confront a survey, you are more in you intend to write a 5, satisfied. It's some psychological thing. Okay, before the mode, we have the sum, right? That's a summation. Add all of them together, and we have variance. Okay, we have standard deviation. Okay, so that's how we create all those descriptive statistics manually. And if we are lazy, we do not want to create them by all those fancy functions, and it's just too many. Cannot remember all those functions. There's a nice package called psych. So if you don't, if you haven't installed this package, just install the package psych. Then load this package psych. In the package psych, there's a function called describe to automatically give you the descriptive statistics. See, if you describe this, it will give you all 3 quality, timeliness, and cost service. give you variable 1, 2, 3. This is not variance, okay? This is a variable, right? We have number, okay? How many counts, right? We have 514 observation. That's rows, right? That's a rows. 514. Numbers, we have mean value, standard deviation, median value. They also have something fancy, trimmed, math. You don't need to care too much. Min and max, we can see it's a 1 through 5 Likert scale, right? Range, 1 through 4, 5 minus 1. Whether it's skewed or not, kurtosis, standard error, all those descriptive things, okay? But we haven't seen the variance here, right? So you probably need to add variance. Let me see whether they can find the variance. So we haven't seen a variance option here. Right? So every time you got any question about a function, you can type the function name in the helper tab and search. It will give you the document to describe how we use this function. So in this case, I haven't found anything to calculate the variance for each row. So these bars are not variance, are variables. So S, right? Let's see the variance again for the quality of service. 2.34. We haven't found that, right? So describe won't give you variance, but will give you standard deviation and standard error. But the relationship between standard deviation and standard error is square, right? You just square this SD, it will give you a variance. So it's almost like giving you a variance, just not directly. Okay, those are descriptive statistics. You can do it in SPSS. Now you can do it in R with just one function described. Okay. Second, about inferential statistic. Usually we have some t-test, right? Remember, we also have paired t-test, independent t-test. We have, ANOVA. All the things can be done in R. Here, only show you two of the inferential statistics. One is correlation. How can we correlation between variables, especially Pearson correlation for all the numerical numbers? If we're going to calculate the correlation between ordinal numbers, there will be a different thing, okay? Now we just only focus on those numbers. So core, C-O-R, core function, calculate the correlation. So you can see after I type this core, we'll calculate the correlation between quality of service, timeliness, and customer service. I give you, this is a correlation table, right? It's between, on the diagonal, everything is 1, right? On the other thing is symmetric, right? Because it's correlation with each other. And we can see those 3 scores are highly correlated with each other. So quality of service, timeliness of service, customer service, they look like related. It's kind of understandable because if you ask your government to fix a traffic light issue close to your apartment, and if the government doesn't care so much, it takes like months of time to fix just a light. The timeliness of the service is very poor, right? On the other hand, they will probably mark a very poor score for the quality of the service, right? You spend so much time and the lights are still like easily broken, right? A customer service probably won't experience a very good customer service because you may call the government several times. Why don't you send some guy to fix this light, right? So if you call the customer, the government more than 5 times regarding one issue, you probably feel very angry. So the customers won't be very good. So they're kind of correlated with each other. They are very reasonable. Okay. And t-test, remember, independently test to see whether control group and treatment group, they have no relationship, just 2 groups. We try to tell whether they have any difference, right? So here we test this, right? We try to test quality of service and customer service, right? Suppose the quality of service should be independent with customer service because, quality of service is like the city sends some guy to fix your issue, whether that fixing is good or bad. Customer service is your experience with the guy you're talking to, the call center, the representatives in the call center. So nowadays, many call centers are outsourced to a third party. So probably your government just assign this task to some other consulting services to take calls for them. So the 2 different teams. So they're kind of, You may have, very bad quality service from the city government, but very good customer service from that consulting company. So it's kind of independent. Let's test the score, right? Just test it. I'm sorry. Yeah, just test it. So this is the result, the two sample test. Okay, we can see p-value here is extremely low, less than 0.05, right? Something like 0.00006. Mean of x is 3.84. Mean of y is 4.25. So timeliness score is here. Sorry, customer service score is significantly better than the quality of service score. Okay. Similarly for the quality of service and timeliness of service. So here I do a paired t-test because we see quality of service is provided by the city government. Timeliness of the service also provided by the city government because they may spend lots of time to fix the traffic light issue, and the records may be paired. So I just use paired t-test. And we see the p-value is 0.78, which is much greater than 0.05, which means the test is not significant, which means the two satisfaction score are close to each other. They're not distinct with each other. So we can see mean difference is very tiny. Okay. So that's how we conduct t-test. We can also do ANOVA and other thing in our structural equation weight model. We discussed last week, we can use Lavang, but I haven't put it here because it's too complicated and you don't need to do that in our, okay, we just know R can do it. So if you want to do it, you can use it. Also, at last, we try to build a linear regression. So remember in SPSS, we just go to analyze and regressions, and we'll build a linear regression model. In R, it's also quite simple. Just use a function LM, right? So we don't need this summary. We can I put a summary here just to show you the result. So how can we do linear model? We just say let's name a new variable called KCMO 2017 dot linear model. Okay. So LM is the function to conduct linear regression model. Okay. The first entry is the formula. Quality service is dependent variable. Okay, this dot means the rest of the other variables. So we have 24 variables here. Quality of service is dependent. The rest will be independent. But I delete two columns, these two, because those two, timeliness and customer service, those two are also satisfaction score. So I just need to delete those two. Okay, then I go back. So we haven't seen that, right? So quality of service might related to whether it's a phone call service or web submission. How long does it take to solve the issue, whether the issue is solved or not, right? What kind of issue they are confronting, right? Something like that. So we build a linear regression after that and assign this regression model result to this variable, okay? And how can we see this model, right? We need to use a function called summary, and summary this model will show us the result. Okay, it shows the result. Okay, intercept is significant with 4.1812. So this quality of service is something with a benchmark of 4.12, right? And it is statistically significant, which means it depends on all other factors that we do not know. We are not including them in this independent variables. But for those independent variables we are included, we find district 2 is statistically significant here. You see these stars are p-values, okay? It's 0.03, statistically significant. And minus 0.56, which means comparing to, we have 6 districts. So comparing to 6 districts, we can see all others are almost minus, some are plus, but comparing to district 6, district 2 is much poorer. It's like 0.5 score poorer than district 6. So district 2 may got some great, quality of service issue is somewhere, some investigation must be done there in that district, okay? And we also see street problem is also bad because negative means it's bad than the 4.12, right? Most are negative. It's just the one is positive. Public safe is positive, okay? But it's not statistically significant, so it's not so meaningful. Okay, so that means the street score is what? It's 4.12 minus 0.7. So the street score is like 3.4, right? 3.4. That's a street. So it's kind of low. Okay. And mowing is like, there are so many, too much grass and so many weeds around. So you need to cut all of them. Otherwise, like a barren land, some whiteness, that's so tall, those grass. So you have to mowing them. In America, they just call the government to do that. Okay. Especially for public land, not for private land. So this mowing issue is 0.61. So 4.1 minus 0.61 should be 3.5 something. It's a little bit better than street, but still not good, right? Water is also 0.6 something, right? Capital project issue, that's minus 1.12, which is 4.12 minus 1.12, that's 3. In a 1 through 5 scale, that's 3. It's like they give a 3 score to that one. They got a very big issue in capital project. Citizens are complaining about those capital projects, okay? Government-related complaints, that's negative 0.38, which means 4.18 minus 3.08, which means 1.04. So that means some citizens give that government-related issue just 1 star. Okay, extremely not satisfied. I don't know what's happening here, but that citizens, this kind of group of citizens are extremely not satisfied with their city performance, and they are statistically significant. So you have to deal with that. So based on this citizen service survey, we can see the problem of a city government here. So we can see the p-value to reflect the significance. And we can see the estimate to calculate the satisfaction score, okay? And R square is, let me see, adjust R square, it's 0.03. So it's really poorly fitted, but it doesn't matter because we do not want a prediction issue, right? It's only to reflect what kind of request are statistically significant contribute to the satisfaction score. Okay. So that's it for data exploration using R. So you can see everything can be done in SPSS, can also be done in R. So if you are interested, if you want to learn more, you can take some other classes at PIA or in some other places to learn more. Okay, R is just like a computer function here. Okay. Next week, we're going to talk about visualization using R, because you remember in previous weeks in SPSS, the visualization is quite rigid. If not ugly, but it's still rigid, which means you have very little thing to change the graph. What does it look like? But in R, you can do a lot of things, especially for the package called ggplot2. Okay, so let's call it a week.